OSPF the same. It's implemented in Zebra. So if we just look at the OSPF-D, it'll be this. We have seen RIP-D, and this is OSPF-D. And it has OSPF path. The diaspora algorithm is implemented here. The diaspora algorithm. And in the book we have mentioned what function to look at if you want to trace how diaspora is implemented, and also in RIPD you can also trace certain function to see how Bellman-4 is implemented. So both diaspora and Bellman-4 you can identify which function to look at. For BGP, 2 minutes. Okay, it only use Bellman-4 algorithm because it's scalable, and we got the network backbone network is too large. However, instead of using distance vector, it use path vector. So when you tell your neighbor router, you not only tell the distance vector, but you tell the path vector. You tell the entire path. So you tell your neighbor, I can reach X, and the path to reach X is this. And the reason why I tell my neighbors the path instead of just distance is because we want to provide a loop-free inter-domain routing between domains. We need to have loop-free, so I provide the path to my neighbors. Not just distance, I provide the path. And it runs over TCP and routing table because two backbone router could be far apart. Two backbone router could be far apart. They are not immediate neighbors. They could be far apart. In between, there are several routers, but all these routers are intra-domain router, not inter-domain router. So you need to use TCP to protect your path vector, exchanged path vector. And the routing table will keep all feasible paths, not just one path, but advertise only the one path. I mean, one optimal path to the neighbors. So I know how to reach X, I know, but I would take the best path, the optimal path, to advertise and to exchange with my neighbors. I would just tell my neighbor the only path, which is the better path, the best path, even though I maintain several paths. I maintain paths from other neighbors and all the other neighbors, but I would just advertise one best path to neighbors. And again, it could be, even though it's used mostly for between domains, it could also be used within a domain, but not as usual. Usually in between domains. It also supports policy routing, meaning perhaps you don't want, even though we have path to China, we probably don't want our traffic destined to Europe to pass through China, right? That's policy routing, because if the traffic go through China, then you'll be censored. So we can set policy routing so that the traffic would not go through some network. And some protocol messages to exchange the path vectors. I think I'll stop here, and perhaps next time we talk some more on this, and then we move on to multicast routing. So I'll stop here.